Welcome back. In this video, we're going to continue our look at percentage by considering percentage change. Here, the idea is that sometimes just knowing the change in some quantity doesn't really inform you as well as a percentage would. For example, suppose that we know that Sylvia gains 4 pounds, and we want to know, is that a meaningful amount of increase or not, gaining 4 pounds? Well, it kind of depends, right? If Sylvia is a baby and goes from 20 to 24 pounds, then that's going to be noticeable. On the other hand, if Sylvia is an adult and weighs 120 pounds and goes to 124 pounds, we may not even notice. Okay, so it depends on how much Sylvia weighs in the first place. As another example, suppose you get a $3,000 a year raise, which is great. If you make $12,000 a year and now you're making 15 because you've gone up from 12 to 15, a $3,000 increase, that's going to be a quality of life improvement for you. That extra $3,000 a year is another 25% of what you were making before. On the other hand, if you are like a anesthesiologist and you make $500,000 a year, and now you're making $503,000 a year, you may not even notice that extra $3,000. Okay, that's small to you if you're already making so much money. So the point is there that that $3,000, its significance depends in part on how much you were making in the first place. And so situations like that, and the one where Sylvia was gaining 4 pounds, is meaningful, more meaningful if we know how much we were starting with. And so that's where percentage change comes in. Different books present this in different ways with different formulas. Some give us 2 separate formulas depending on whether there's an increase or decrease. I like to do just one formula because it's just one formula and not 2. And so we'll express this just as the percentage change as whatever the quantity is now minus whatever it was divided by whatever it was. And if this answer turns out positive, it's a percentage increase. If this answer turns out negative, it's a percentage decrease. Okay, so let's try it out. Okay, suppose that a child weighed 80 pounds but lost weight due to illness, and now she weighs 75 pounds. We would like to know the percentage change in her weight. So the percent change is what she weighs now minus what she weighed before, divided by what she weighed before. So what she weighs now is 75. What she weighed before was 80, divided by what she weighed before, which was 80. So that's a decrease of 5 pounds out of 80. So 5 out of 80, that is 1/16. I'm going to turn that into a decimal, and from there into a percentage. That's going to be a decrease of 0.0625, or 6.25%. She lost 6.25% of her body weight due to the illness. Okay, another example. Here it says the average soft drink size has increased from 13.1 ounces to 19.9 ounces over the past 2 decades. We want to find the percent increase. And then there's a source there, which we don't especially need. Okay, so the percentage change is going to be what it is now minus what it used to be divided by what it used to be. Okay, it's increased from 13.1 to 19.9. So the present amount is 19.9. It used to be 13.1. Okay, so that is an increase of 6.8 out of 13.1. And that's about 52%. Let's put an approximately equal in there, 52%. All right, so again, what that's doing is that increase from 13.1 ounces to 19.9 ounces, which is like 6.8 ounces more. To get a sense of how big that is, we divide by the amount that it used to be, we see that it's increased by over 50%. Okay, John Smith decided to decrease the number of calories in his diet from 3,250 to 2,100. We're going to find the percentage decrease. So take a minute, pause the video, try this yourself, and then restart it and see how you did. Okay, so what his calories are now is 2,100. What they were was 3,250, divided again by what it was, which is 3,250. So they decreased by 150, no more than that. I lost the first digit there. 1,150. And that's out of his original amount, which was 3,250. That's about a 35% decrease. Okay, so that's a decrease of 35.4%. Okay, two more examples. So here it says Jen used to make $48,000 a year, I guess, but she got a raise and now she makes 49,440. We would like to know what percent did she get? Did she get a 2% raise, a 3% raise, 5%? What did she get? So what she makes now is the 49,440. What she used to make was the 48,000. So that was a dollar amount increase of 1,440 out of the 48,000 she made before. And that's a 3% increase. And she got a 3% raise. Okay. All right. So here, let's try the next one. A jacket was originally $120, but it goes on sale for $96. We would like to know the percentage decrease. What discount was it? Okay, so percent change. Whatever it is now, which is the 96 minus what it used to be, which was 120, and what it used to be was 120. Okay, 96 minus 120, that was a dollar amount decrease of $24, saved on a jacket that was 120, so that is a 20% discount. So you save 20% on the jacket. Okay. This one a little different. For this one, we know the size of the percentage change and we don't know the amount that it is now. So here it says a bottle of shampoo normally is 32 ounces. They sell a bonus size in the store that says 30% more free. The bottle's a little bit bigger. We would like to know how much shampoo is in this. Okay, so we're going to set it up in a similar way. We have the percentage change. We have what it is now minus what it was, divided by what it was. And we're just going to fill in the blanks with the information that we have. We know this time that there's 30% more, so the percentage of increase is 30%. We'll put that in as a decimal. What it is now, I don't know that, so that's going to be my variable. What it used to be, that is before it was increased, was 32 ounces. Okay, so the was's end up being the 32. So this is a little equation in X that we're going to solve. So first we'll multiply both sides by 32. And then we'll add 32. So X will be 32 plus 0.30 times 32. And then in hindsight, that should make sense. We start with the original amount, which was 32 ounces. And then what got added to it is 30% of, remember of means multiply, 30% of the 32 ounce originally in the bottle. Okay, and so that's going to be 32 plus, and then 30% of 3.2 is 9.6 ounces. And so that is going to be 41.6 ounces. Okay. All right, so that's all of the percentage change for the next part, we're going to just see some examples involving using percentages to solve story problems. Okay, so in this next one, it involves tax. So here it says an item costs $60 and we're told that the tax rate is 8%. We would like to find the amount of tax and the total. So to find the amount of tax, that's where we take in this case, $60, and we're multiplying by the tax rate as a decimal. So we'll turn that 8% into 0.08. And so multiplying 60 by 0.08, we get $4.80. Okay, and this is the tax amount. When you multiply the rate, expressed as a decimal, by whatever the base amount, here the price of the item, $60, multiply those two together, get the dollar amount in taxes. Then, of course, for the total, we'll take the $60 price of the item plus the $4.80 we were going to pay in taxes, get $64.80. Okay, next. A new computer costs $900. We would like to know the price after tax if the tax rate is 9%. So we should find the tax amount first. Tax amount is going to be 9% of 900. So you'll notice that this is kind of a question like, what is 9% of 900, even though it's not said that way? So we're finding 9% of 900, and so that's going to be $81. And then adding that, price after tax. So that's going to be the 900 for the computer plus the $81 in tax, $981 total. Okay, so that's pretty fun. Let's see what else we've got. Okay, so in this one, we know the price of a car is $18,500, and we know the dollar amount of tax, and we want to know what the tax rate is. So the tax rate, let's call that R, is such that the 1665 is R times 18,500. We multiply to take a part of the total amount. So we'll solve for R by dividing 1665 by 18,500. This will give a decimal, 9% for the decimal, or 0.09, and then that's going to be 9%. So the tax rate here is 9%. Again, we've divided the part by the size of the total to arrive at that value. Okay, the next part has to do with commission and tips. So let's take a look at some examples. Here it says a salesperson earned a commission of $3,575 for selling a $32,500 car. We're to find the commission rate. So this question is really just like the last one, only instead of tax we're calculating, it's a commission. So you're going to calculate it in the same way. Is $3,575 out of $32,500. And that's 11% this time, which is pretty good. Okay. In this one, it says a clerk in a paint store earns a 2% commission. We want to know how much she will earn for selling an $18 can of paint. So in this case, we want to know what is 2% of $18. That's what the question is really asking. So we need to know what is 0.02 times 18, and that's going to be 36 cents. Okay. Great. All right, let's try this one. Suppose that your total for dinner is $46. If you leave a 15% tip, we'd like to know how much that is. How about 20%? And then what about doubling the tax? So for a 15% tip, probably the easiest way is to think about 10% first. 10% of $46 would be $4.60. 5% would be half of that, and so is $2.30. So altogether, that's going to be $6.90. Okay, so for a 15% tip, it would be $6.90. For a 20% tip, I would again figure out 10%. 10% is easy to calculate, right? That's the $4.60. If you were to make 20%, then you're multiplying 10% by 2, and that's going to be $9.20. Okay, for a 20% tip. Okay, some of you may have heard, maybe your parents do this, to calculate the tip, they double the tax. What is up with that? It doesn't have really anything directly to do with the tax. It's just that in a lot of places, a tax rate is somewhere around 7.75% or 8%. And so if you double the tax, that gives you an amount somewhere around 15 to 16 to 18%. That's why you may have heard people who say, well, let's just double the tax to calculate the tip. Of course, these days, as you know, often at the bottom of the receipt, they'll tell you all these percentages, or you can, of course, pick out your phone to calculate. But back in the day, you could calculate the tip easily, or approximate tip easily, by just doubling the tax, because of the fact that it was around, the tax is around half of 15%. Okay. Okay. Discount and sale price. When you're figuring out the discount on an amount, again, the discount rate, often given as a percentage, is multiplied by the original price to give the amount of discount, which is then subtracted to give you the sale price. Okay, so let's say that somebody is interested in buying a $75 bookshelf. It's discounted by 20% because it's got a dent in it. Let's say how much you're going to pay for the bookshelf. So first we want to know what's 20% of $75. I'm going to make 75% there, sorry, $75. Okay, so again, we can multiply 0.20 times 75. You're going to get 15. Okay, that's the amount of the discount. 75 minus that $15 discount is going to be $60. We'll pay $60 for that discounted bookshelf. Okay. Here's one for you to try. A couch is normally $2,200, but now it's 40% off. We would like to know how much is the discount and then how much you're going to end up paying for the couch. All right, so let's see how this came out. So the first thing that you want to do is figure out what the dollar amount discount is. So that's asking us basically what is 40% of the 2,200. That's a lot of money for a couch. So 40% off. So what's 40% of 2,200? So that's 0.40 times 2,200. So 880. Okay, so that's an $880 discount. So 2,200 minus 880. That's really sloppy. Sorry. 2,200 minus 880. That's not a lot better, is it? Okay, looks like 1,320 for the price of that couch after the discount. We took 40% of the 2,200 and then subtracted it from the price of the couch. Okay, all right. We just have one more discount question, and then we'll do a little bit about interest. Okay, so here it says a jacket is normally $80. It goes on sale for 25% off. We've done stuff like that before. And then also because you work there, let's say you get a 10% discount. How much are you going to end up paying for the jacket? So first, let's calculate the 25% off. So 25% of 80 is going to be $20. That's a quarter of it, right? A quarter of 80 would be 20. This is how much you're going to save. So then we'll take 80 minus the 20, giving $60. Okay, that's the price that just anybody would pay with it being on sale. But now, because you're an employee, let's say, you make an additional 10% off. So now we're going to take 10% off of the $60. Okay, 10% of 60 is $6. So 60 minus the $6 will leave you with a price of 54. So you're going to pay 54. Okay. So it's important to note that you're not getting 35% off, right? The percentages don't just add like that. So just to be sure, let's see what is 35% off. I know you had 25% off in the first place, and then 10%. You can't add the percents to say, okay, well, it's 35%. So 35% of the 80 is $28. It's $28. And so then if you save $28 on this $80 jacket, you would end up paying $52, which is, of course, not the $54 that you really would pay. The reason for that is, of course, that the percentages don't add. An easier example to illustrate this, okay, let's say that the jacket is normally $80, and then it goes on the clearance rack. They've taken 50% off, and then they're also offering another one-day sale, let's say for another 50% off. Okay, so one-day sale. Okay, so here, the discounted jacket is 50% off because summer is coming, let's say, and then they also have a one-day sale for like an extra 50% off. Well, it's not going to be a free jacket, right? Uh, so the jacket, normally $80, they're going to take 50% off, making it 40. But then when they take the other 50% off, it's going to be 20. You can't just add the 50%, get 100% off, making it free. So there is that. All right, so that takes us to the end of some of those applications. The last application we're going to look at has to do with interest. Interest is a fee paid for the use of money over time. If you borrow money from the bank, they don't get to use it for some other purpose. If you lend your money to somebody else so they can pay their rent or something, then you don't have the money to spend on yourself. So that's compensation is involved, and that's interest. There's a couple of different ways that interest is calculated: simple interest and compound interest. Compound interest is dealt with another time. We'll do simple interest right now. The formula for simple interest looks like I equals P times R times T, where I is the dollar amount of interest, P is the principal amount. Notice the spelling here is PAL, not PLE, like a principal, like something you believe in. This is like a PAL, like the principal's office, principal. Okay, the interest rate, that needs to be expressed as a decimal, and then the time, how long the money is borrowed for. Okay, so these components make up interest. Of course, the more money you borrow, the more interest you pay. That's where the principal comes in. The interest rate is set by agreement between the borrower and the lender. And then the time, of course, how long you borrow the money for makes a difference. If I lend you $500 for the weekend, then that's different than me lending you $500 for 6 months, right? Because I don't have my money for longer, it's going to cost you more. Okay. The rate does need to be written as a decimal, and the time units in the rate, like 4% per year or 4% per month or whatever, the time units in the rate and the time need to match. We'll see an example like that where it matters. Okay, so let's try it. Find the simple interest after 2 years on $500 at an interest rate of 12%. So interest equals principal times rate times time. The principal, we're told, is $500. The rate is 12%, and the time is 2 years. Okay, so 2 times the 500 gives the 1,000, and then 12% of that is 120. So the interest alone would be $120. Of course, the borrower would need to pay back the 500 also, making it $620, but the interest charge alone is the $120. Okay, let's try. We did that one already. Let's try this next one. Let me change this just slightly. Okay, here, the 2 years, we're going to change that to be 30 months. Okay, so a student borrowed $1,500 at 20% interest, which is huge, for 30 months. We would like to know how much interest she paid. So a key fact here is that we cannot just do I equals 1,500 times 0.20 times 30. What's wrong with that is that the time units on the rate and the time need to match. An example that illustrates this, I'll do that out in a minute. But in the meantime, let's change that 30 minutes into years. The 20% interest is going to be an annual rate. And so we need to change 30 months into years. 30 months is 2.5 years. 1 year is 12 months, so 2 years is 24 months. 24 to 30 is another 6 months. That's a half year. So 2.5 years. Okay, so then let's multiply all that out. That works out to be $750. It's kind of a lot. Okay, so that's the amount of interest that would be paid. I wanted to give just another quick example that illustrates how the time units there need to match. It's not in the context of interest, but it works the same way. Let's say that you have a job that pays $40 an hour. Let's just say, which is not bad. And so let's say that you go to work one day and they're overstaffed or something. And so you go home after 15 minutes. You're there just for 15 minutes and they say, you know what, go home. We've got plenty of people. Go home. So to figure out how much you get paid for that 15 minutes, because you've clocked in, you work for 15 minutes and go home, you clock out, you should get paid for that 15 minutes. Unfortunately, right, it's not going to be 40 by 15, right? It's not that. Instead, you'd need to think, well, 15 minutes, that's a quarter of an hour. So a quarter of an hour at $40 an hour would give you $10, right? So you need to change that 15 minutes into hours in order for it to work out correctly. All right, so that takes us finally to the end of section 3.2, which has been about percentages. Let me know if you have any questions, and then have a great day.